Okay, it's November 22nd, 2024. I'm Doug Fairbairn with the Computer History Museum, and I'm here to conduct an oral history with Miin Wu, who is a previous colleague of mine from 40 plus years ago, and so we're delighted to have the chance to get together again and learn about what all the wonderful things that he's been up to. He's currently chairman of a company, Macronics, in Taiwan, and so we're eager to hear his story from the earliest days in China to great business success in Taiwan.
Thank you, Doc.
So in that way, we'd like to actually ask you to tell us a little bit about your very early life. Where were you born? What was your family like? Do you have siblings? When were you born? And sort of tell us about the early life and the family environment that you grew up in.
I see. Well, actually, I was born in China, a small town next to the big city called Wuhu. And actually, my grandpa was the police chief locally. During the Civil War, he think it's better for us to stay out of the town, the home, for a while to settle down. So actually, my father and my mother carried me all the way from my hometown in Huanghuai all the way to Fujian. You know, actually, it's a Fuzhou City of Fujian. I don't know how long take him to bring me to that places.
Carried you, huh?
Now, I was only 5-6 months old. You know,
so this was in 1949, so there was a lot of.
Actually, that is 1949. Yes. So
there's a lot of turmoil in Japan,
yes,
China at the time.
Yes, and we are. My father actually went to this Fuzhou City because there's a military port in that city. Mm-hmm. So my father, I guess, my father think maybe he has opportunity to meet his brother, who is in the military service. So hopefully he can find someone carry us, leave to China. So fortunately, yes, my father met with one of the old acquaintance, and then they bring us to the ship. And after that, the ship went to Hainan Island. Mm-hmm. You know, today Hainan Island is famous for the tourist places. Oh, okay. But they bring me there. But however, the condition in the ship is very bad. So actually, according to my father, I almost dying during this journey. And eventually, my father says I was saved by the Chinese doctor in Hainan Island. So I barely survived. So stay for a few months, and then they got order. The army get order that the family of the army need to go to Taiwan. So then on the way we from Hainan, and transport to the Taiwan. That's where we finally settled over there.
Now, were there any other siblings, or were you only child?
A big part.
Were you the only child?
Yes. I only, 4 or 5 months old. So that time, my brother only born in Taiwan.
Taiwan. So. Okay. So what profession was your father in?
Well, eventually my father settled in teacher. So he's teaching in high school mainly. So all his life he was a teacher in the high school. Maybe he was invited to teach in the college for a few years, but he's high school teachers. As you know, the high school teacher has very stable income and condition, but a very low income.
Low and stable.
Yeah, so I calculate when I go to U.S. and my father actually making $40 a month. And study Stanford is very expensive. You're talking about 15,000. So very obviously, I have to find other resources to survive.
So you went to school. It sounds like your father, perhaps your mother, were interested in making sure that you got a good education.
Yes, because my father was a teacher, so, but however, I think at that time I really don't need my father put a lot of attention on me. I'm survived, but not very smooth. Okay, for some reason I'm not very good in the examinations. So I have my up and downs. So during my high school times, university, and so on and so forth.
So you went through high school and university in Taiwan,
Yes,
is that right?
yes. I also get my master's degree in Taiwan as well.
Oh, okay.
Yes.
In what subject? In electrical engineering?
Electrical engineering, yes, yes.
When did you find interest in electronics, and did you do work with electronic equipment before you went to university, or how did your interest develop?
Well, at the time, I think Taiwan is very behind the world places. So I remember I was in the senior year, and we start to touch on some of the very old equipment like motors, transformers. So there's no such things called microelectronics at the time. So I learned the semiconductor when I was in the senior year. This all on book, so we even don't see what is that. And my teacher, my professor, actually learned maybe half years earlier than me, and then he taught us on semiconductor. So really, in the college, we have to heavily rely on ourselves. I studied the electrical engineering, but that time I already decided to enter into semiconductor.
Mm-hmm. And what years did you attend university? When did you enter and leave?
1966. I was entered the National Chengkong University WWII department. So I spending 4 years there. After that, I went to military service for 1 year. After that year, then I went down to get in my master's degree in National Chengkong University. So part of story is very interesting because that time, when we in the military service, we have to try to to have a lottery type thing, right? So you have to pick which organization you're supposed to go. That time, I'm afraid to go to we call the Golden Horse Award. So what is Golden Horse Award means is this two islands called Jinmen and Mazu is in front. So if we get that award, we have to go to that place to defend the country. So at that time, so I thought that if would be a advantage for me that to take the graduate school examination. So if I pass, I can decide it. If I got a Golden Horse Award, and then I can go to school right away. If not, then I go to military, so I have more freedom later. So that's how I did. And fortunately, I didn't get a Golden Horse Award, but I already passed the entrance examination for graduate school, and then I decided to take the military first and then go to the graduate school.
Interesting. So did you do anything electronics related in the military?
No. I was in the they call this what they call is this supporting unit. So basically, even in this supporting unit, I own a communication station, wireless. Okay, so I was the station chief of that one, and then trying to getting exercise in the Morse code. So at that time I learned a lot of Morse code. I forgot all of them. I only remember di da, something like that. But I forgot everything.
Yeah, yeah. I learned Morse code in the similar time frame and don't remember very much.
Yes.
So you finished the university, and what was when you were going to university, what was your plan? What was your idea that you wanted to do?
Well, I Actually, I want to work in Taiwan at the time after I get master's degrees.
Mm-hmm. So that was in 72 or?
72 to 73, yeah, 2 years that time. But however, in the 73, before the graduation, I went down to visit some of my senior in the department. I found out what they do is not much fun. It's just lead the operators, really not no research
No
or development
engineering,
work,
yeah,
no
right.
engineering work whatsoever. Right? So I decided that's not what I want. So I decided to go to the overseas. At the same time, my wife at the time, my girlfriend already in the U.S. So either I have to pursue further or I have to give up. So with the two reasons, I decided then I want to go to the overseas.
So did you know English by this time? Had you studied English along the way, or?
Well, actually, in the school, we mainly learning the reading. We don't have a conversation per se, right? So in a way, that would be very difficult. But however, coming to United States, I need to have a TOEFL test at the time. Otherwise, I cannot. But since I didn't plan on in the beginning, so what I did is I decided to go to the places where don't require TOEFL test.
What kind of test?
TOEFL, TOEFL, or something like that. I mean, it's the testing to decide whether you have enough capability to study in the United States, right? So, but if without passing that one, the school will not give me any permissions.
Right.
So I have to pass that. But however, in the short time, I don't have a chance. So personally, I went to the U.S. Library Department in Taiwan, and to search, which university don't require TOEFL test. Of course, all the U.S. based, you cannot, right? So I look at the Canada and also UK. So I find out two universities don't require. UK, in the UK, the University of Glasgow, now it's engineering school, and they don't require that. So I apply University of Glasgow, and then in the Canada, I also find a university they don't require it. The university called McGill University.
Oh, yeah.
I didn't know who McGill is, right? So, but anyway, I applied both school, and I find out eventually the Glasgow gave me permission or admission, and then the McGill not only gave me admission, but also the financial assistance.
Oh, wow.
So I decided to go to the.
So you went to McGill in Toronto?
Yes.
Uh-huh.
No, Toronto in Montreal.
Oh, Montreal. I keep getting those mixed up. Right?
Yeah. So they are the, the Montreal is a French-speaking city,
Yeah.
but they are the only one of the two universities speaking in English. So I went there without private knowledge. So it was an interesting experience.
So you actually attended McGill for
Yes,
a period of time?
for 1 year.
For another
1 year.
master's degree?
No, actually in McGill, they require 3 years for the master engineering. So I decided that would be too long. And since my wife married me, she has the PR in U.S., so I can move to U.S. So I decided to apply another university. Here I applied Stanford. But in Stanford, I decided to study a different field. I already have a WWII department, WWII degree. So this time I'm already decided I'm going to study semiconductor. So the next move is to study material science.
I see. So did you actually attend McGill University for a
Yes,
period?
for 1 year.
For 1 year?
Yeah.
Okay,
so-
and then you moved to Stanford. So did you get financial assistance at Stanford as well?
Yes. Otherwise, I can afford. As I said, my father is only getting $40 a month. There's no way he can support me, right? So I have to find my own way. So I think that also really helped me to find way to survive, because later when I get into entrepreneurship, I think that's very important. Being a poor people,
Right.
we have to find how to survive, right? So that's
exactly. So who did you, so you went to Stanford and earned another master's degree in
Yes.
semiconductor, and that was in 74, 75?
Well, actually, I graduated end of 75, right, with a master's degree. So I start work on the 76, I believe.
Who was your advisor, or who did you work most closely with at Stanford?
Clayton Bates, Professor Clayton Bates. He's the only black professor at the material science at the time. Later, I don't know how many years later, he moved to the Washington University, St. Louis. So he's no longer with Stanford.
Yeah, so he was, so you were studying material science,
Yes.
Semiconductor physics and that kind of thing.
Yes.
Not design or.
Yeah, no, not the
Okay.
mechanical, not design, yes.
Okay, so, and your wife was working in this area in the.
Yeah, that
Silicon
time,
Valley?
because I only counting on the research, we call it research scholarship, something like that, right? So it's not enough. So my wife also working.
So you came to Stanford, you wanted to study that, and did you have a notion of what Silicon Valley was all about and entrepreneurship, or were you just interested in finding a job, and what was your view of the world you found yourself in at that time?
Well, while in the school, we understand that the Stanford produced a lot of entrepreneur. So I think that gave me the first impression. And also, my father was a teacher, and teacher was very poor. So I decided, I'm not going to get into a teaching job.
Don't want to do that.
No. So I decided to, eventually work in the industrial. But of course, I have set up a goal that hopefully someday I can start my own something. That was very important because once I set up that goal, start from the first job. So every job I change, I have a purpose of that. It's not just changing the job. When I change it, I want to know what I'm going to learn. So every learning will be toward eventually my career later.
Was there any professor or other individual that had a particular impact on your direction, or
Not really.
You were sort of heads down, get yourself out? So you graduated, and what type of firms did you look for employment, and what kind of job were you looking for?
Okay. Actually, when I studied in the material science, I also took WWII courses, the IC fabrication, I think offered by Professor John Mendel's.
Yeah.
So I did very well in that course, and I decided, this is the semiconductor will be eventually my career. So in the beginning, I have several offers. Some are military research, some are different discipline area. But I decided semiconductor is something I want to learn, so I took the lowest pay in the semiconductor area. So the first job I got is Siliconics. Okay, that's near the 101. You can see the Siliconics.
Yeah, right in the center,
sign.
Siliconics.
Yes. So I went there to start learning.
In process development?
Actually, yes. Yes. I found out Siliconics is a very interesting company. They are small, but however, they give engineer lots of freedom. Even though I'm a development engineer, I find out that's really helped me to apply some knowledge during the semiconductor process development. For example, one of the things I did is, the Shockley has provides a table, the implantation, when the implantation going into the silicon, how deep the species can get in with different energy, right? So that's a table there. So in fact, I remember that time I like to somehow verify that whether how true it is. So in Siliconics, I did my own study with my own way and come up with the exact answer. So that's interesting, But I think that is one of things I did. Another things I did is because in these high voltage devices, what I need to do is I'm going to provide the thick CMOS or PMOS devices. At the same time, I'm going to get the breakdown voltage or whatever. So in that case, the PMOS devices and the bipolar device, how are you going to match? How are you going to match? That's one is MOS, one is bipolar, but the bipolar beta, the amplification factor will be important too. So when you're growing thick oxide, how you balance these two? So everybody has a difficulty to get that answer, but I took a different approach. I thought, well, in that case, how can we just using dry oxygen or wet oxygen? Because that's only two-way available. So that would be very difficult to make the technology work. So I decided to using the oxygen and the hydrogen to burn in the tube to do that. But that process was dangerous, right? If you do it wrong, they could be explode. But then I think, I think that's important. So I really mix that, so I can have a dry oxygen and the wet oxygen. I can try to draw the curve, Then I can get different thickness for that. So I can really making my bipolar device and the MOS in a perfect match. So that's the kind. I found out it's very, very useful for me to learn a lot of basic things.
Yeah, get real hands-on experience.
Yes.
What technology were you working with in Siliconics at the time?
At the time they called BIMOS, the bipolar PMOS technology. That was the one.
And the end product was high voltage semiconductor components?
Well, I cannot remember exactly what the end product is. But at that time, I remember that time they using contact printing, all kind of old stuff. And you have to learn how to do all these different things. I cannot remember the product itself. I know at that time Siliconics produced a lot of small detector chips and things like that. I wasn't aware of the technology they are using, the product they are producing.
Was there anybody that really helped you or served as a mentor there at Siliconics, or you worked mainly on your own, or how did
well, I have my supervisor actually is Austrian, but he pretty much leave me alone. Yes, I think that's a good point. Later, I think there's another fellow replace him to be my supervisor. I remember his name called Henry Gao, G-A-W, and he actually, the Gao and Wu actually is the same because he's from the Philippines, so the pronunciation a little bit different. So he was UC Berkeley graduate. He's a very, very smart gentleman. So I learned a lot from him.
So how long did you stay at Siliconics, and what was your next
only
move?
a slight over 1 year.
Only 1 year?
Yes. And I decided to go to a little bit bigger company. So at that time I wasn't thinking to apply. I just got an opportunity, and I got an offer from Rockwell International in Newport Beach. Yeah. So I decided, well, this is a big company, and also have a military military experiences. So I decided to join the.
So you moved to Southern California?
Yes, for a little bit over 1 year. So.
Just another year there.
Yes, that's where the learning. The learning
what did you work on there?
Well, I forgot the exact project I'm working on, but what I remember is at the time Rockwell has a major problem in their fab. I remember, so I joined it. They sent me to solve the problem called the PMOS technology. They have a PMOS technology, and then they have NMOS technologies. At that time, there's no CMOS, so P and N. Right. So the PMOS, what happened is the yield go down to zero, almost zero. So I think all their engineers cannot solve the problem, so they all go on to different project. So end up they give me the PMOS project, try and ask me to solve the problems. But in 3 months, I solved the problem for very interesting work. Okay, I remember what I did is I don't know what the problem could be, but I take a wild guess. So I asked the test engineer help me say, can you measure the I/O devices, the breakdown voltage, right? I/O, because that's where the first thing you do. So what I find out is the good yielding wafer and bad yielding wafer, the breakdown voltage, good yielding is one value and higher. The bad wafer is one value, the same value go low. So clearly there's a punch through somewhere, right? So what I did is I go in there gradually to observe that, my guess, at that time I guess the problem is really a pinhole through the thick oxide, and that pinhole, eventually when you do the deposition, the impurity depositions, they form in another isolated diffusion layer, and then eventually, you break down. You're going to hit that one, and then you start from zero again. So in that case, that's why you give you different the breakdown voltage depend on where the pinhole is. So that pinhole is come from the spin dryer, and I find out, and then I solve that whole problem in 3 months.
So they must have had a product waiting for that. They were backed up trying to ship a product.
Yes, and actually I solved the NMOS problem later. So with this 2-1, my experience is, they want to give me a big raise. But however, the whole microelectronic division head cannot make that decision. He cannot sign. Has to send to the headquarters in Dallas.
Oh yeah.
To a
big company.
To sign the big raise. So I got a big raise over there. So
you saved them a lot of money.
Oh yeah, of course. At that time I was a very poor young low salary engineer, right?
So you spent a year there and you solved a couple of major problems, and then where did you move next?
And what I moved is then I got an opportunity to go to Intel, because before I moved, actually, they R&D center in Anaheim. They trying to hire me, but I think the Newport Beach people don't release me, so I decided to go. Now I have an offer from Intel, so I went to work on the Intel.
So did Intel find you, or did you find Intel?
I forgot exactly this situation.
Yeah.
So I got an offer from Intel, and then I work in the Santa Clara TD. So.
Doing process development on what technology did you work on?
That time I'm doing, I cannot remember the technology, but I'm working on the EEPROM technology.
Oh, okay.
So, and the E-square prom, so EEPROM and E-square prom.
So you started on non-volatile memory a long time ago.
Yes, that's exactly. Not in the flash at the time, but it was EEPROM and the E-square prom technology.
So this was, when did you join Intel? About 1978 or?
78, 76, about 78.
And who were you working with at Intel on this EEPROM technology?
Well, at the time, my immediate boss called Jim Lee. He's Chinese, but was raised in U.S. when he was young. Okay, so he speaks very good English, and he can correct me a lot of my report. When his boss, and then Jim Lee's boss is more famous, called Eddie Harari.
Oh, yeah.
Okay, so at that time, indirectly, I worked for Eddie Harari, yes.
Did you have much interaction with him? Did you?
No. But I did something, his invention, he invented this so-called split gate of non-volatile memory devices. So I did a study, and then I give him a report based on my study. So at that time I said for the aligner that technology won't work. The reason is the aligner has a big misalignment. So in that case, if you want to have a minimum coverage, and then the chip will be very big. So I think that technology will work is when the wafer stapler come in. If you remember the lambda rule, you develop, that's where the it's really depend on the equipment driven. So for the stapler, I think will work better, but for aligner, it's not going to work.
So you must have learned quite a bit about non-volatile memory technology, and
Yes.
served you well in the future, I presume.
Yes. So I did a lot of change for them. For example, used to be, I remember when I work in Intel, that their issue problem is the cell, memory cell is defined by the diffusion and the poly. But that approach will have lots of problem. The reason is, in the issue problem, you're trying to move electron from the substrate to the poly. But then, you have a burst peak during the process. So burst peak normally is weak side. So if you do that, actually you could damage the cell very easily. So at that time, I suggest them to dig a hole inside and then to make that happen. So eventually, all the EEPROM become making that way.
So how long did you stay at Intel? 2 or 3 years?
Actually, about 3 years. The reason I leave is very simple, because you see, I am very interested on the non-volatile memories. So at that time, there's a job opening called the project manager for the, or they call program manager for the EEPROM. That's the project. I really like it. So I'm pursue that opportunity. Unfortunately, they pick up another Indian fellow. And eventually they tell me that I lost that battle because my English is poor. So, well, anyway, so I think Indian people speak better English. I agree. But anyway, so, and then they give me, in turn, they give me a program manager for thin film. The technology, I really don't like it, not my interest. So I decided at the time, a friend introduced me to WWII technology. So I had an interview with Gunnar, and then they hired me. So I went on to WWII, joined the startup, because that's exactly what I want. I stay in the big company, learn the technology, then I want to go to the startup so I can understand how to really set up the wafer fab, so on and so forth.
And that's where we met.
Yes, that's exactly.
So when did you join VLSI Technology?
I cannot remember exact time. I would say it's probably the end of the 70s or early 80s. I cannot remember exact time.
Yeah, it must have been early 80s, because we didn't get the funding until December of 80 and start real work until 81.
So I was employee number 9 at the time. So.
Okay, so you were right at the very beginning.
Yes.
Yeah. And so VLSI didn't have a fab at the time.
Yes.
And so what were you doing then?
Well, basically, I'm helping them. They are going to build a fab. So I was the one to planning on the new technology they're going to do, right? So at that time, they are trying to get read-only memory devices. Right. So they have the customer, and then they hire some designer. That's one of designer actually with me in the last 35 years in Micronics.
Oh, who is that?
Tom Yu. Yeah. He's a very tall guy, right? Tom Yu, he joined me over there, but he was a design guy to design the ROMs, and I will be the technology guy to develop that. So that's why we work together to establish that. So in the beginning, even we don't have a fab, but there's a requirement from the customer side, so we decided to use in the foundry to do that. And I remember the foundry called Universal Semiconductor in San Jose. So I remember that time, the best they can produce is one good die per wafer.
Oh, no.
3-inch, okay, but still, one die per wafer is not going to be profitable, right? So we tried it, but when we built up our fab, and then my first try in VLSI fab is 60% yield.
Oh, my.
So that was quite
First
different.
run, 60% yield,
Yes.
huh? Wow. So, and in between there, VLSI produced wafers in Japan with Ricoh,
Yes.
right?
Yes, that's in the Ricoh.
Yeah.
And I was the one to transfer technology to Ricoh. Yeah, at that time, VSI transferred a few technology. One go to the Korea called KIET, and another one is in Ricoh, Japan. So I helped them to build up those technologies.
And did you work with Shindo-san at that time?
Yes,
Okay.
yes. So my direct contact is called Watanabe-san, but the Shindo-san was on top of the whole thing. So I met with the Shindo-san.
All right, we'll come back to that later.
Yes.
So you transferred the technology to Ricoh,
Yes.
and you got very good yields, I presume,
Yes, yes,
in
yes.
their fab.
Yes, yes.
And that was a huge win for VLSI Technology to
That's
be able
correct.
to produce those ROMs for I'm trying to remember the name of the company. Coleco,
Yes, yes, yes.
I think, was the customer. Ron Casper had signed up
Yes.
for millions of dollars worth of ROMs.
Yes, that's why I went to Japan several times. So.
Yeah, okay. Interesting. So did you got the process up and running on the VLSI fab
Yes.
they built in Milpitas or in
Yes.
San Jose, whatever. And so how much longer did you work on any other projects? Was that sort of the main conclusion of your work there? Did you continue to do other things?
Well, basically at the time I was the one man. Later I hired a couple guys work for me in the process development area. So that's where we do developing the new process at the time.
So you had to develop, I mean, you had worked on polysilicon and other lower levels, but you hadn't done metal and other kinds of technologies
No,
in the past, right?
metal gate, no, at the time. Because at that time I think people were already talking about CMOS, things like that. So I wasn't doing anything in that area. But however, I cannot remember exactly what I did. I remember I bring up the ROMs, and I have not much knowledge about anything else. But when I work in the VLSI, another thing is very important for me is since they don't have lots of process engineers at the time, and they have lots of credit to learn the equipment, since we're going to buy a lot of equipments, so they have the credit. So I have an opportunity to learn few equipments like implanters, the things like that. So
you're able to educate
I got
yourself,
really
huh?
hands-on, opportunity on that.
So were you responsible, along with Gunnar, to specify all the equipment in the fab and that kind of thing?
No, actually it's not. I'm only just doing the development and using whatever equipment they are available.
So tell me about how what else you might have worked on at VLSI and when you decided to leave and where to go from there.
Well, I've been through all the R&D experiences, startup experiences. So now I think I'm lack of experience on sales, right? Because I don't know how the sales works, and I have no idea about the financial part. So that time I've been actually 4 colleagues in VLSI, we decided to go out to start something our own.
Oh, okay.
So the other 3 are from the product engineering side, and I'm the only process side. So that's where we go out, and when we go out, that we actually transfer some, because I able to transfer some different technology to Japan. At that time, I transferred ROM technology to SHOP in Nara, and also transfer ROM technology to Taiwan, and also help transfer some EEPROM technology to Korea. So that really helped me to understand the outside world.
So you had left VLSI with
Yes.
these 3 or 4 other
Yes.
engineers and set up, what was the name of your company at that time?
Micronis Inc.
Micronics Inc.
Yes. So there's a story about why I'm using Micronis International Company Limited, but at that time was Micronis Inc. I started learning how to do different things, right? So at that time, we are developing I remember the only product I remember today is called the whistle, blower, something. They basically what happened when you whistle it, and then the device will be a beep. So in that case, if you forget your key somewhere, you whistle it, and they will tell you where the key is. And at that time, Taiwan is very gung-ho on that. Yeah. So I went to Taiwan to selling. You remember, it's very tiny chips, and then selling for $1 per piece. The 95% gross margin, consumer product. That's experience. Yeah. I like very much.
So where did the idea or technology for that come from?
Well, actually, it's just from a lots of channel we know that people are looking for different things. Mm-hmm. So these devices, we can do it very quickly. So we find a designer, we can just do it, and then manufacturing in Sunnyvale, there's a company called Orbit Semiconductor. Mm-hmm. The Orbit Semiconductor is the first one I know, the true wafer foundry company. Mm-hmm.
So tell me what the name of that was. You said
the Orbit.
No, but
Orbit.
the device.
You mean?
Yeah, that little $1 device. What was the?
Yeah, that we basically is all they call some founder, key finder or something.
But what was the technology, or what did you call it?
I cannot remember. Okay. I think the foundry was done in orbit, so whatever technology they have. And then, they did it, so I'm just selling. At that time, I'm more in the selling side, not in the technology side.
Right, so you had to go find customers in
Taiwan. Yes, that's where my strengths, because out of 4 partners, I'm the only one from Taiwan, so I can go there to sell the products.
But you also did business in Japan and Korea
Yes.
and other places, so you got
that's through different channels, different people, yes.
Okay. So you really did get the experience on this business development and sales side.
Yes, that's very good experience. Yeah. So since 4 of us together, so we all need to learn something about financial, right? So even small, but we still need to learn just financial. So that's where I prepare myself from the beginning to that stage on a different thing for year, 2 years, something like that.
All part of your plan. All part of the
Well,
plan.
that's kind of part of my plan, so.
So did you envision that you would continue to start things in the U.S., or how did you end up going back to Taiwan? Tell us about how you moved Macronics from Inc. to international.
Yes. Actually, when I see we 4 of us, we make good living. I bought my first Benz because we make profit from these key finder chips. Mm-hmm. So, but I don't think that is something I want. Mm-hmm. So I talked to my colleague. I said, well, this is good, but it is not what I want. I want to do a little bit different. Mm-hmm. At the time in the U.S., VC don't invest on the hardware. Mm-hmm. So they are not interested to invest into wafer fab. Mm-hmm. So Taiwan is just beginning. So the people willing to invest on the fab. So that's the big difference. So I decided, okay, if the U.S. didn't invest in the fab, so the only way is go back to Taiwan. So that's where I going back to Taiwan to start this company.
Okay, so you left VLSI in technology in about 1984 or 85, is that right?
I started the company, my Micron is 89. So
89.
So these 5 years we are doing this Micron's Inc. stuff.
Right, so from like 84 to 89.
Yes.
In the U.S.
Yes.
And then in 89 you went back to Taiwan, and so what was your vision of the type of company? You didn't want to build these simple key finders or whatever. What did you have in mind when you went back to Taiwan, and what was your pitch? Did you raise money from venture capital in Taiwan?
Yes.
So what was your business plan, or what was your business vision at that point?
The business proposal I did is actually I'm trying to build a company doing the SoC. System on chip. This is 1989.
Very
Very ambitious.
ambitious, long-term thinking.
Yes. But, for young people, sometimes we probably don't think about that, right? So that's where my business plan called for that. So because that business plan, I knew I need to build a lot of technology to make the system on chip. So we need to have a processor, we need a video, we need audio, we need a connectivity, you name it. We have a mixed signal or the requirement. So what I did is, I went down Silicon Valley to recruit a lot of designers and then convince them back to Taiwan. And works. Actually, in 89 and 90, 2 years, I recruit approximately 40 engineers, moved them from U.S. back to Taiwan.
These are design engineers, not
design.
process engineers.
No. A lot of design, because that's a difficult part. But in Taiwan at that time, they are all doing reverse engineering. So those engineers, to me, is useless. So I'm bring the forward design people from U.S. and move them back and hire local graduate, fresh graduate to form this company. So idea is, of course, trying to come up with SoC. But before we do the SoC, I have to come up with individual product. So actually in Taiwan, we did a lot of interesting product at the time.
Before we get there, so how did you convince 40 engineers, all with good jobs, I presume?
Yes.
And these were all Taiwanese engineers?
Some are Hong Kongese.
Okay.
Yeah. Well, the reason is almost similar to my experience in Intel. Right? Intel, I lost the battle because I don't speak good English. So that means English is the ceiling for a lot of Taiwanese engineers. They are very smart, but they cannot communicate well. Because in Taiwan, we are not trained to speak, to hear. This is our problems. So I think it's not that difficult to convince this guy, because they know we are coming in big team, not only just one or two people.
So you had to go to Taiwan, raise some money.
Yes.
And you got only venture capital. You didn't get any help from the E3 or the government or anything like that?
No, the government, zero.
Okay.
It's all from VC. They not only they invest a little bit of money, but they group private sectors to invest into this company.
I see. So how much money did you raise at that point?
I believe it's about the 800 million NT dollars in the first round. 800 million, we are talking about is maybe 20 million US dollar. And we're going to build fab.
But you also had to, did you pay to have all these engineers pay their cost of moving back to Taiwan?
Yes, I actually helped them. I know that the system work in the U.S., right? When you move engineer from one location to another location, you actually pay for the moving. Yes. So I learned that. I asked my the import-export people to learn from these people, and then we actually contract someone to move all their luggage back to Taiwan. I see. So that was good experiences.
Yeah. And your parents were still in Taiwan, is that right?
Yes. But at that time, I believe I moved them to U.S. So in fact, in '89, I think they are in the U.S., not in Taiwan. So, but I was the first one moved back to Taiwan.
And so you sold the VCs on the idea of building an SoC, and you had the engineers to do that. So you got back to Taiwan. Now you're starting from scratch. You have nothing, right?
Yes.
So what's the first step in building towards an SoC?
Well, the first is you have to do some design, right? When you do design, it costs you money. that time I thought if I follow the traditional wisdom, and the company will not going to survive because very expensive. And when you build a fab, actually the money I raise even not enough to pay the fab construction.
Right.
So I choose a little bit differently. So what I choose is how about to have customer first rather than you do everything. Once you have a customer and then you know exactly what you can do, before I build a fab, I can really running some business. It sounds like very easy, right, thinking, but how to get that? So I'm lucky enough at the time, the 80s, the Japanese wafer fab or semiconductor company are way powerful than the US.
Yes.
So in the 80s, if you remember, the U.S. semiconductor company really called for government help to negotiate with Japanese government to open their door, right? So I took that opportunity. So what I did is, and now you remember, this is Micron Inc. So I use in Micron's International. So it's the same name. So pretending this. You use Micron's Inc. as the company to solicit the business in Japan, and we are doing all the manufacturing.
I see.
So by doing that, and then my customer Nintendo have to give me 20% their requirement, even though I have nothing.
Right.
So we can sourcing the design, sourcing the production, and then mark my MX, and then they can ship to U.S. to fulfill government requirement.
But you didn't even have a fab at this point, right?
No design, no fab, nothing.
So if you won part of this business, your engineers did the design?
Eventually, we will do that. But however, I start business without nothing, without anything in place. So I think that is the strategy I'm playing. Just simply, they have to buy from U.S. based, and I'm using that opportunity to know this guy and then to let them know us. And then we went on to talk to Samsung and some company in Japan, so they OEM to us. I think with the intention they want, actually this Korean company want to sell the product to Nintendo directly. But Japan and Korea also have their own conflicts, so they don't want to. So selling to U.S. is perfect. So I fully took advantage of that opportunity to enter their door.
So this was from Nintendo to placing orders for what, ROMs or something from you?
The ROM to Micron's Inc.
Right. But then you were buying them from Korea.
Yeah. And then Micron Inc. give us the order. We do everything. We just ship to them, pretending this is a business from Micron's Inc.
Right.
So they don't have to do any work. I just sourcing from someone. I don't have to do work where I'm going to build in our fab. So that really help us, because once we build a fab, then we know exactly we have a business right away.
Instead you've already got a pipeline.
Yes.
So when did you build the fab?
Well, I started with the year 1990, but it took about 2 years, 3 years to complete the fab, and then develop technology and then design the product. By then it's already 1993, 1994. But however, this business already.
So all during that time you were shipping product to Nintendo and other customers?
Yes. By using other people's product.
Using other people's product.
Yes.
Very clever.
Just because I know how to take advantage of that, what's happening.
Right.
But we demonstrate that we are going to do that way.
But they must have known where the product was coming from,
Yeah,
right?
yeah.
Everybody
they
knew
know.
what was going on.
They know.
At least they could say they were buying from Micronix Inc. They didn't, but still coming from Korea.
They don't care, right?
They don't care.
They just need that mark.
Right.
So they can register in the SIA, say, this is come from McGill Inc.
Right.
It's a US-based company.
Got it. So you had several years of doing this.
Yes.
reselling
Yes.
Korean products that generated a lot of revenue, which you then used to build your own fab.
Yes, yes. Not only that, we can, I did a lot of interesting things. This is the first things. We exercise our manufacturing people, we are making money. But at the same time, that's still not enough for my engineering work. So what I did is using my connection in Japan. And that time, NKK, I think if you remember, we have been, VLSI has been working with NKK.
Yeah,
on
steel
the,
company to build fabs,
yeah, to
right?
build a fab. You remember that,
Yeah.
right? So then what I did is I just went back to them, say, hey, I have a design capability. Tom Yu was the designer for VLSI, and then, we can license you a product. So they just start a company. They want to license product ROM and to sell to Nintendo. So they agreed to negotiate with me. So what happened is I negotiate with them, and then in 3 different product lines together, I collect $16 million US.
Wow.
And
3
that-
different product lines.
on 3 different product lines. And then I think we have to do ourselves anyway. So either we're using our own money, now we are using my customers' money to develop that, and we can deliver the product.
And were
to
these
them.
ROMs also, or were
No. There some are EEPROM and EEPROM, the ROM, things like that, different technology. So together, 60 million at that time is a lot of money. So that really helping me to develop the engineering resources that way.
But the engineers you had hired and brought over were they memory designers?
No, they have all kind, as I say, all kind.
Okay.
So memory designer is only Tom Yu,
Okay.
and then he just hire local people
To help them
train.
and
Yeah,
so forth.
so
So, but the others had other design skills. Did you build things?
Yeah,
did you
we do the,
designs other than memory?
yeah, we do the. At that time, I did 10 base Ethernet controller, 100 base Ethernet controller. Actually, that chip was we sell to HP.
Okay.
It's a big company, right? So HP, and also we did the first the world scalar chip for the LCD TV, the first, and also for the overhead projection. Original idea is a Japanese company want to have that, so we actually designed the chip for this Japanese company.
And where were those products produced?
That's in Taiwan. Eventually is in the I believe in the TSMC or.
Okay,
I
not by
forgot.
your own fab. It
At
was,
that time, we just start the
just
doing the
doing
memories. So,
foundry stuff. Okay.
yeah, so we also did 32-bit CPU chips. So we do the DSP, digital signal processing. So all kind of That's why the first 10 years I grow the company from 0 to $1 billion US by selling all these different
To how much?
to $1 billion
$1 billion US dollars?
in 10 years. Yes.
Wow. And initially that was just using other people's fabs and so forth. And
No, that's only first few years.
Right.
And then after I built it, I start move everything back. So what I did is I negotiated with NKK for the design money. So I also work with TSMC. So they are building the Angel Fab. So I went to talk to Don Brooks, the president of the TSMC, and I convinced him that you are building the Angel Fab. But by the time you build up, you develop technology, you find a customer, you start ramping up in full, that will be 4 or 5 years. You can lose a lot of money.
Right.
So here we got a space for you. So you give me a money to buy 10,000 wafers output equipment, put in my places. I run for you. Your customer, I'm not going to using any of your capacity. I do it for you. By the time you bring up the business, your fab up running, you bring back. And then
So you were a foundry for TSMC.
Yes, in a way. But I'm not doing forever, right?
Right.
The deal is for 3 years. So I did for 3 years. Every wafer we ship them, we pay them some money back. So in 3 years, they move all their business to their new fab. And then I got this 10,000 wafer capacity I can use for other people. At the same time, I pay in full. So these 10,000 wafers I got, I paid nothing. That's how I grow the first 10. I have first 10,000 wafers. Now I add another 10,000 wafers from the TSMC deal. Then I have another 20,000 from my customer. So I exercise my opportunity with Nintendo. I'm already big supplier for them. Yeah. They need that. They like our technology. They know we're capable to do that. Right. So I went there. So they have lots of money in the bank, US dollars. So I asked them, can you loan me this time? Loan me this amount of money so I can buy 10,000 wafers capacity, but you have to commit business to me. They agree. So I got the third 10,000 wafers again without paying my own money.
So at the same time, your acquaintance Shindo-san was building his own company,
yes,
Megachips,
yes,
in Japan.
Yes.
Simultaneously with.
Yes, yes. But they are the design house, right? So by the time we do a little bit differently. So this time we both together to take care of Nintendo. Yeah. Nintendo become bigger and bigger in our business. So we need a Japanese friend to help us to manage the business. So that Nintendo business is Shindo-san and us are taking care of Nintendo-san. So, but however, this is just how I grow the company without having our own resources. But my impact to the computer industry is much bigger than that. Because I have a lot of connection in Japan, so my understanding at that time, in the 80s, Japanese company actually dominate the semiconductor industry. So I remember out of top 10 semiconductor company revenue-wise, 6 are Japanese at that time. The reason, in my opinion, is they have the discipline to make a production much better, so they can produce better quality product and the better cost products.
Yeah, their yields far exceeded that in the U.S.
Precisely. So when I started a company, so the number one I have to compete is not U.S. company. I don't believe they are my competitor. Rather, the Japan is. So I have to dealing with Japan. What can I do? So in the beginning, I believe Taiwanese engineer and the operators do not have the same discipline like a Japanese. If they do not have the discipline, what can I do? So that time I take a bold move. I decided that I want to run my fab by computer rather than by people. At that time, no other people ever done that. Not in the US, not in the Taiwan, not in Japan, not in Korea, none to do that. Because there's a lot of logistic issue I have to solve. For example, when you run the fab, how do you know which lot you're going to use, which lot they're going to produce, what kind of recipe you're going to put in. So that's why I put a barcode into my wafers. That's how I started the whole thing, okay. So at the time.
So each container of wafers had a barcode on it?
Each wafer has.
Oh, each wafer had a barcode?
Each wafer has a barcode,
okay.
Not a container. Wafer is more important because that eventually the final product, right? So every single wafer has to start with a barcode there. Well, now the fab is run by computer. We all know one of the good things about a computer is you can collect a lot of informations. Whether you like it or not, whether you can use it or not, but you can collect. So what I decided is I want to know all this data, what that means. So in 1990, 35 years ago, I hired a lot of statisticians into the company, have them to work with the semiconductor profession. So here is one mathematician and here semiconductor. They don't know each other, and then ask them to work together.
Speak a different language.
Yes, well, force them to start
to
talking the same language,
Yeah.
right? So that's what's the learning curve we are doing. But however, if you look at today's world, that means 35 years ago, I actually started AI concept in the semiconductor manufacturing.
Were you using any robotics, or was it mainly
Just-
computer information
Just
gathering and tracking? And
Just computer information. Moving the wafer, so we do have the track on the top, right? But however, the from the stacker to the equipment, and we're using human being to move, much efficient. When we move the equipment, and then before they started, they would read the barcode, so to make sure everything is doing right.
Yeah.
So that's how we did it. And then we find out that's very efficient. Efficient means is we can make the product with a better quality than Japan and a better yield than Japan.
So is this sort of combining sort of the Deming quality principles with high amount of data that you could get from the computer? Is that?
Well, at that time, I don't know about Deming's.
Oh, okay. So you
I
were
have
just-
no idea. All I'm saying is we have lots of data there.
Yeah.
How can we use those data? So I have no idea what the data can be used, what the direction we can use. But it turned out to be we are continuing to improve our yields, our quality. So after 30-some years, the quality is so good. When I say good is, I use the example. We are using automotive industrial as a data to compare. So what is, we are choosing Japanese business, US business, and the European business in the automotive area. We look at RMA from what we shipped. So right now, we actually can measure RMA in the unit of a PPB, part of billion.
Part per billion.
Yes, for automotive. Where you have to
Yeah.
remember, not consumer.
Right.
Consumer
no,
will be much
is
lower.
Automotive has the highest
Precisely.
reliability requirements.
That's why I use in the highest standard to test our fab capability. So today, not only we are 1,000 times better than our competitor in terms of RMA rate, but also it's proof that our parts today is very good in the application of space, aerospace. In the US, you have a few companies doing that, and they test my parts. We are the only one pass in the world. We also proved by the European Space Agency on that to prove that our parts, they actually just buy the parts from market, and then they test their way, and also they prove our parts, both NOR and NAND, are much better than our other competitor.
Okay, so let's go back. You finally got your fab started, and you're using this computerized data collection and so forth. But in terms of the actual products, it seems like you currently produce mainly memory products, mainly non-volatile memory products. Is that right?
Yes.
So tell me, how did that come about, and what was your product focus at the time, and what is it now?
Well, if you look at SoC, we need a lot of logic, but then you also need the memory.
Yeah.
So which memory eventually will be important? Flash, right? You need to put the data in there. You need to change in it. Whatever you do, write and erase are important.
Right.
So read-only memory is not good for that. So from the memory point of view, I know eventually I'm going to do flash, because in the system area, the flash is only solution for the memory solution, for the system solution. So that's why we need to build a fab for the memory because that one you cannot using anybody's fab to do that. Logic you can, but not memory. So our fab will be focusing on the most difficult part is memory devices. So that's how it started. So it's been 30-some years. I forgot exactly what we did in the logic area, but I believe that our logic is come from the foundries. Okay, so that time I remember one thing. We developed this 100-base Ethernet controller. We convinced HP using our parts. They bought a big volume from us. So in the beginning, I stepped forward to order a lot of wafers, and we can ship. So my program manager, he's afraid, order more wafers, and turned out we lose the business because we give the HP a hard time because they got no shipment from us, so he had to go back to National Semiconductor in that sense. So this is just one example. That's what we.
So those Ethernet chips, you were still using outside fabs. You weren't building that yourself.
Yeah, but no, we are already not doing that because 10-base is the best is too old for that.
Right.
Now you're talking about the million.
Yeah, but at the time when you were first doing it, even then you were
we're
sourcing
using
it outside, right?
Yes, that's correct.
Okay.
That's correct.
So you built your initial fab. When did you got your first fab up and running in 95 or so?
Actually,
94?
I would say 93, 94 time
93,
frame.
94.
Yeah.
And since then, fabs have become much, much more expensive.
Yes.
Are you keeping up? How are you keeping? Tell me about your fab strategy.
Well, that's the first fab I built is 6-inch fab. Okay. That was maybe the world's last 6-inch fab. Okay. And then people start building 8-inch fab. So we managed to build an 8-inch fab also, since we make some good money, and then we are able to do that. And then eventually in the, I think 2010 timeframe, then we built a 12-inch fab. So we bought a old fab from nearby, and then we upgrade ourselves. So that also costs a lot of money. Fortunately, I managed to make all this money from the market, so we are able to build a fab by ourselves. So actually I have 3 fab at the time. 16, 18, 112. Right. And eventually we sell the 6-inch because this cannot be used anymore.
Not effective.
So
yeah.
I still maintain the 8-inch and 12-inch.
Okay. And does that meet your current requirements, or how do you see yourself growing it from here?
Well, I think that's, as I said, first I need to make sure I'm fulfill the current production requirement, and at the same time we will have a place to develop new memories. And one of new memories like this. This is we call the 3D NOR devices. Right now, all the NOR are the 2D. Okay. So this is the world first 3D NOR devices with the 4 gigabit in these devices here. So we need a fab to develop new technology. Yeah. So in the 3D NAND area, we are developing today more than 300 layers of 3D NAND. So we need a fab to do that. So that's very expensive, yes.
So what dimensions are you working with at this, how many nanometers?
Well, for the 2D, the most advanced geometry we are doing is a 19 nanometer for 2D NAND, okay? Because below that, the flash no longer work. Okay, so I think that's the limitation. But for 3D, it's much better because, in fact, 3D you don't need lots of advanced lithography equipment because you make the cell vertically, so you can make your cell bigger, no problem. But
300 layers, huh?
Yeah, you go through 300 layers. So you have to find a way how to etch down, right? Because 300 layer sandwich, you need to very sharp knife, you can.
And 300 masks, I mean.
No. If you do that, that will be, you cannot survive.
Yeah, that's okay.
You do it, you only do couple of mask layer to cut through. I see. So you need to have a good equipment. etching equipment. So fortunately, the lamp are, if you remember, WWII technology, when we started, the first etcher is come from lamp, the barrel etcher. Now they are able to produce the etcher we can cut through 300 layers.
And finer geometries than 19 nanometers. They're down to what?
Well,
what geometry would the?
Well, equivalent-wise is like maybe I would say 6. I can't remember either 6 nanometer or 0.6 nanometer. Equivalent-wise is very small, but that's cheating. So the point is, you do it vertically that you can save the cost that way.
You don't have to buy these $200 million lithography machines from.
No, I don't need to. That's only for the larger foundry guy. They need to do that because they are truly trying to produce 1 or 2 nanometer transistor, so they need that.
So how has, just in sort of broad terms, how did your business expand? You started with with non-volatile memories, and sort of, and you still make ROMs, is that right?
Well, basically, it's not really. We categorize as ROM, but actually now it's all either flash or NAND flash or 3D NAND based.
Okay, so it's pre-programmed NAND.
We are doing for ROM application.
I see.
So ROM application means is you only program it once, but you read many times.
Right.
But flash, basically, you can read and program many times, right? So in that application, we will make sure is you can read more reliable, but not on the programming side. So.
Got it. Okay. So tell me about how your business evolved from the 90s to we're 20, 30 years later. What, and you're still focused on memory, variety of memory products, right?
Yes, I think as I said in the beginning, we did this mathematics work with Fab itself. I think that was a big impact. The big impact means is, the people knows how to improve the processing, or improve relationship between the process and the equipment. So the impact is huge. So right now we are applying for IEEE to get a milestone on this methodology. So I think that is, most people probably don't understand the impact of that, but all the Taiwanese companies learn from me, and then that's why the manufacturing yield is so good. So everybody think, well, how come Taiwan produce very good yield on that? So this is the methodology really make it works. And right now, used to be only a few companies. We are the latecomer. We beat the U.S. company and Japanese company on that. But now there's a competitor from China. So I don't know how they did that, but they can sell very cheap and still claim profitable. This is kind of a situation we are facing today, so we have to do something different. So what I did is, I know this is not going to be forbidden to have a China competitor. So we already did all the standalone memory already. So I'm thinking right now, how can I move from the standard memory into memory system solution? So once we move to memory system solution, then it will be difficult for Chinese company to copy or other Taiwanese company to copy for that. So right now, most of the move is going to that direction. So one of the move actually is we are trying to using 3D memory. They have a lot of transistor in there. So if we know how to using their transistor to do the calculations, mathematics, so they can be very good for edge applications. So basically, we are trying to using the 3D memory as either core CPU or the second CPU in addition to your core CPU, right? So that's the way we're thinking from application point of view. There will be other
Trying to move to a
application
real system on chip kind of thing that you've always wanted to.
But first is doing the mathematics is important. So that's why we are doing that way, moving in that direction.
The mathematics applied to what?
Mathematics is very interesting because we are first using mathematics for the wafer fab.
Yeah.
But now we are using mathematics to develop algorithm.
To do what?
Algorithm.
Algorithms,
Yeah,
right. You
because-
mean like AI kind of
Yeah,
math?
yeah.
Okay.
Because right now, you see, when you doing the chip is very expensive now.
Yeah, absolutely.
So what happened is instead of you using random logic to develop that, why not you insert a algorithm so they can upgrade very easily? If you can think through what kind of application you do, so using algorithm to define what you want to do in the next 5-10 years, so your chip will be much more flexible. Instead of every time you have to go through the expensive way to create a chip. So I think system chip,
You can actually do that in a memory configuration,
Yes.
so that you.
Precisely,
Right.
precisely. So I remember my design chip. First, I give him this mathematician. He said, "What can I do with this guy?" He have no idea, but later you find out he's very, very good addition to his team. Because electrical engineering don't know much about the math, right? So when they're dealing with algorithms, will be nightmare for them. But this guy can solve them in split second, very easy. So I think that's why I start believing in the cross-discipline learning, because everybody need to learn different things.
Right. So tell me about Mechatronics today. How big a company is it? Is it a public company in Taiwan?
Yes,
or?
yes. Actually, Mechatronics is the first public company in the high-tech area. You know, Taiwan used to have a class, Category 1 and Category 2, so only very limited big company listing at the time. So I personally convinced the government officers. One is for development purpose, one is for economic minister. So I convinced them that the government should not the one to decide who is supposed can be listed, who is not. Let investor to do that. Right? Investor is much smarter. They know the who is invest. Let them to make decisions.
Right.
You know, your government don't have to make decisions. So finally, I convinced them. So they open up that we call the high-tech category. And I was the first one listed.
And when
in
was
Taiwan.
that? When did you become?
1993.
Oh, wow, very early on.
Yes. And also I was the first company listed in NASDAQ. First company from Taiwan listed in NASDAQ. You can see I'm very aggressive on that. I'm not just sitting there wait the things happen.
So what's the annual revenue of Mechatronics? How many
Well-
people to size the company for me?
Well, you know, the in the last 4 years, the highest we achieved actually is about the close to 2 billion. But last 2 years, because the economy situation, so we're actually below $1 billion US dollar. So that's a big differences. Okay. But anyway, so that is not a problem, and we are just losing a little bit of money. But the key is, are we going to create a different company? So you ask me what my plans will be happen, and I believe that we are developing few things. One is, of course, the memory in computing in memories or memory search. This type of applications will be very interesting. Particularly, a lot of application is in the medical area, so we think that will be things for us to do. But my next project actually is create the world leading SSD, solid state disk. So we are developing this 300 layer. Maybe later will be 500 layers 3D NAND. And then we also developing the controller for that applications. So that controller we are not a system company. So just our people working very hard trying to do that is not going to work. So we actually work with IBM. So IBM is a system company, and we're trying to learn from them to see what the 5-10 years later, what the kind of computing industry will be changed. So we're trying to create this controller to fit into that future requirement together. So I want to come up with very interesting solid-state disk for certain application, not the generic type of this SSD, but it will be, very unique and have growth potentials.
I want to switch to some of your other personal stuff. Is there, before we do that, is there other things you wanted to say about Macronics, the company, and sort of what you've achieved over the past few?
Well, as I said, the number one, I think the Micron has been the number one NOR flash supplier, for a few years, because at that time we are growing very, very rapidly. But as I said, I want to emphasize that Micron is the most major contribution is really help the technology go down to 1 nanometer because the yield, right? Because everybody claims they can do the advanced technology, but the problem is someone can do 90%, 80%, some people only 20%. That means you cannot compete, right? So I think in Taiwan, all the fab can really produce good wafer because this mathematics and the one I invent. And because that invention, I also won the Taiwan Presidential Innovation Award 2 years ago. And I was the first one from industrial winning that kind of award, because most of our professors, research guy, and I'm the first industrial people did that. So I think the Micron actually has a major contribution to the world on semiconductor. So, and also I don't know, you'll be covered on my other stuff on the foundation thing.
Yeah, I want to talk about that in a moment. I just wanted to make sure that we covered Macronics. And I guess, Macronics has had I presume, a significant effect on the evolution of Taiwan in the semiconductor business. It isn't just you growing a company, but the impact on the country overall.
Yes, and also listing. To break the listing barrier is the important part of that,
So we talked earlier before we started the recording about you're starting up an educational institution. Tell me where that came from and what the focus of that is.
Okay. Well, the year 2000, when we make $1 billion revenue and a lot of profit, so our board started discussion, what can we do to return to the society? So at that time, we forming a foundation, the Micron's educational foundations. What at that time we want to do is we want to encourage innovation, because that's what Micron's do all the time. We trying to create the new things. And then I think can we do something better than the current system can do? So we decided to forming two different award. One is we call the Golden Silicon Award. This Golden Silicon Award is aimed for WWII student, regardless they are a bachelor, master, or PhD student. They can all come in to compute on the annual basis that you create some idea, you either you do it in the system level application or you do it on chip level innovation. So actually we have design group and also application group, two groups. So we are giving the people money for rewarding what they are doing. So, and that was a big impact to Taiwan. The reason is so far we have more than 10,000 people come to this competition, and that really helped Taiwan industrial growth.
So this was open to anybody in Taiwan,
Yes.
and you would give out awards, monetary awards.
Yes,
Mhm.
monetary awards, yes. And we believe that's very important. So I think that is one. So far, almost every student in the WE department, when they're ready to graduate, they all participate in these competitions. Okay. The second one is for high school students. So we like to encourage people to do some work, not in the big challenge work, but whenever they see in their life, they see something interesting, they can go there to explore that fact and then come up with the answer. So we call the science award for the high school student. So it's about the same amount of people participate, and a lot of the come from the good high school, but even we still have a lot of from the industrial type of the schools. So it's interesting for them to really participate. So far, we have these two different competition every year, and we have this is already 24, 25 years now. So we believe a lot of people benefited from that competitions. So.
And so, did you actually set up a school in computing? I thought I'd read something about that. But
Yes, I think we, with these two together, I graduated from National Tsinghua University, so I thought maybe I need to help the school doing something a little bit different. Instead of just giving the building, so I like to find a more aggressive way. So this is what we call the Miin Wu School of Computing. Okay. They using my name to name that. Right. But however, the idea is trying to find the world leading computer scientist or professor that teach in Taiwan to bring up the advanced knowledge for computing, because that is the weakness for Taiwan. Taiwan has been very strong in semiconductor now, but we are very weak in computing. So
you bring professors from
the
overseas.
intention, but for now we're still unable to do that.
Okay.
Yeah. So I think we are still searching for the successful formula at this moment, and so I think we are hoping to work with a certain university in the U.S., and then we're trying to bring some student to work with them, and hopefully that will be get started. So it is a very slow start, because it's unlike in U.S. U.S. is much easy, because you already have a lot of the best university professor here, and once you start like Stanford, Berkeley, MIT, and College Mellon, they can start this program very easily and find the best professor to lead it. Right. And in Taiwan, we do have a problem on that.
So, what are your? Are you spending full time with the company today?
Yes.
And do you have? You've mentioned some of the things where you've philanthropic things, you've donated funds. Are there other activities or organizations that you're involved in today that you want to speak about?
Well, actually, I also participate several foundations, and most of them relate to the science technology. For example, Wu Jianxiong Foundation. Wu Jianxiong is the lady physicist. She is getting the Nobel Prize. She's Chinese, right? So that's why we're using that name to set this foundation, trying to educate young scientists. So I was the board member of that fund, that one. I also donate some money annually to make sure we can create some interesting activity for young scientists. Okay, so that's one of the activity we're doing. I'm participating. Another one is Li Guoding Foundation. Who is Li Guoding? He actually established the early Taiwan Science Park, and also to start the ERSO in the way. So, he is very good officer and very clean, unlike most of the politicians. And then he actually getting recognition, and also in Taiwan they memorize them as one of the Taiwan contributor. And I was also in that board to make sure, we can continue to support people like him.
So early on, I just wanted to touch base on something you had mentioned earlier, and that is that you were concerned that maybe the Taiwanese engineers didn't have the discipline of Japan. Do you feel that's still the case?
Yes,
and
strongly.
What about compared to the U.S.? Is the U.S. number 3 in that category?
Oh, that'd be even worse. So I think that's why the U.S. Doing the manufacturing is terrible. Believe me, just terrible. So I think but however, the U.S. innovation is number 1 in the world. I think that's because of the culture, right? So when the U.S. government doing the CHIPS Act, some people ask me my opinion about CHIPS Act. My opinion is they move in the wrong direction. They trying to do the manufacturing. I think that's not going to be good for national security. I think no problem. So my feeling is that the CHIPS actually really put the money into system development area, so keep American way ahead of competition in the world. That is the best way to do it.
Well, of course, the reason why the U.S. government chose to do that was because the threat they felt from, the risks they felt in Taiwan or others in the geopolitical world, and China and that sort of thing. So how do you deal with the international tensions associated with and you're in a business that is the center of that, so.
Well, be honest with you, I think we don't have the influence to the government. So I don't think we can deal with that issues. My opinion is this: regardless what the political issue or the regional situation, I think to the private company like Micronics, we just do whatever we do the best to invent new ideas, invent new product, invent a new technology. I think that's the best way, because we are not government. We don't have that capability to decide that. So why bother to waste my time on that?
Right. Keep your head down and focus on being as great as you can be.
Precisely.
Yeah.
That's my opinion. Yeah.
So what about Miin Wu, the person? When you aren't worrying about how to expand and make Micronics even bigger and better, how do you spend your time? Do you have interest in golf or sports or activities, or are you just focused on making your company as great as it can be?
Well, I don't play golf, okay? But I have a strong passion to develop new technology. I always want to come up something do better for the society, for the world. So that is what I'm doing today. I'm not really counting on money. Because I made mistake in the beginning, because I don't start a company in the U.S. I start in Taiwan, but the way they measure is totally different, right? So today in the U.S. you can very easily to be rich, because you can start a company with very little money, and eventually, if you success, you can make lots of money. But in Taiwan, the system is different. You have to, like everybody, put $10 a share to buy it. The knowledge don't worth anything. A little bit, but then it's not going to be worth. So anyway, so that's already passed. I'm already in the last quarter of my life, and I like to do something interesting. I want to do something for the good of the world. So
Right. Do you have children?
yes, I have two.
And are they in Taiwan or?
No, that they are all in the U.S.
Yeah, in the
So,
U.S.
they were born here, so
Uh-huh. Are they in technology or?
no, they do nothing about technology. So that is challenge work. Okay, in my opinion, only if you have a passion to do that. Otherwise, that will be very, very bad job.
So I hope you get to see them on your periodic trips to the.
Yes,
US?
yes. Toward the end of the year, I'm going to see my daughter in Hawaii. So.
So what else? Are there other things that you wanted to make sure that we discussed in this interview?
Well-
We feel that you've.
Well, as I said, not only I'm doing very good things for Taiwan, I also donate money for material science department of Stanford. So I hope that also I have some return to the arm matters. So.
Are you able to recruit students from like Stanford and other places for U.S. universities?
Used to be we do, but right now I think in Taiwan the student is very good already. So that didn't mean we have to hire students from here, particularly under the current situation, it will be difficult to recruit anybody from U.S. to Taiwan. Yeah. So I'm fine. I think I'm still enjoying my life, and I believe I will have a lot of other contribution in the computing area. So
Yeah, you've made a huge contribution to the industry, to your country,
yes,
and you're still at it. More to come.
yes.
Well, congratulations.
Thank you.
Thank you very much.